Hello, this is Stefan again from schristoph.online. Today we'll talk about my latest blog post on replacing the generic Amazon Polly narration on my agent demo with my own clone voice, self-hosted on Amazon SageMaker. Let's see how it came together, and the one gotcha that cost me 20 minutes. It started with feedback. A few people watching my agentic payments demo said the same thing. The narration sounded like a robot. They were right. It was the Polly messy voice. Polly is genuinely good, but a managed service gives you a fixed catalog, and a fixed voice is never your voice. So I asked, what would it take to narrate the exact same demo in my own voice without sending it to anyone else's API? The model I picked is Qwen3 TTS, an open weights release from Alibaba's Qwen team. The reason is simple, the weights are open, so I can run it in my own AWS account and feed it my own voice with no third party in the loop. Two small checkpoints do the work, and they fit together comfortably on a single GPU. Here's the model itself on GitHub. This is the OpenWeights Qwen3 3TS repository. It's Apache 2.0 licensed, which is exactly what makes self-hosting viable. You can pull the weights, run them on your own hardware, and there's no token or managed API gating your access to the model. Now, the deployment. The key decision here was asynchronous inference, not a real-time endpoint. SageMaker async inference queues requests through S3, and crucially, it can autoscale its instance count all the way down to 0 when idle. For a workload like mine, where I render a video maybe once a week, that means I pay nothing for the GPU between runs. Here's the architecture in one diagram. The client uploads the input to S3, calls invoke endpoint async, and the endpoint reads that payload, runs the model, and writes the wave result back to S3 where the client posts for it. S3 in, S3 out, and a GPU endpoint that quietly scales to 0 between requests. That S3 indirection is exactly what lets it idle at no cost. This is the AWS documentation for asynchronous inference that the post leans on. It spells out the model, requests are queued, payloads go through S3 up to 1 GB, jobs can run up to an hour, and the endpoint can scale to 0. This page is the authoritative source for the behavior I'm relying on. Now, you might ask yourself, how is async actually different from a normal real-time endpoint? A real-time endpoint is synchronous, you call it, and wait, and it keeps at least one instance warm so it builds around the clock. Async puts the payload on S3, hands you back an output location to poll, and can scale all the way to 0. The trade you're making is cold start latency in exchange for 0 idle cost, and a sharp follow-up. If you just want 0 idle cost, why not serverless inference? Because serverless has no GPU option today. A 1.7 billion parameter text-to-speech model on CPU is just too slow to be useful. If your model is CPU friendly and bursty, serverless is genuinely worth a look. For a GPU-bound model like this one, it was off the table. And here's the gotcha. With the endpoint scaled to 0, I fired my first request, and it just sat there, queued. 20 minutes later, it timed out, still at 0 instances. The cause is documented behavior. The backlog target tracking policy scales down to 0 fine, but a single queued request never exceeds the target, so it won't scale back up. You need a second scale up from 0 policy to reliably bake it. So you might think, why not just keep one instance warm and skip the cold start entirely? You can by setting minimum capacity to 1, but then you pay roughly $1.40 an hour around the clock. For a GPU, I use a few minutes a week. For a demo pipeline, scale to 0 plus a wake-up policy is simply the better economics. For an interactive product, the warm instance would be the right call. The fix is described right here in the autoscaling documentation for async endpoints. This is the page that explains setting minimum capacity to 0, the backlog per instance metric, and the optional step scaling policy. You need to wake the endpoint from 0 on the very first request. Worth reading before you build this pattern. Now a fair challenge. Isn't this just vanity? Polly works fine, so why self-host at all? Mostly fair, and I say so for a generic pleasant voice. Polly is the right default. Self-hosting only earns its keep when you need something a managed service can't give you, and here that's my own voice, kept entirely in my own account. If I only wanted a nice generic voice, I'd have stayed on Polly. Here's the payoff. The very same demo from the first post, re-narrated in my cloned voice. Same pixels, same walkthrough, only the narrator changed. But the interesting part isn't the model. It's the pipeline that puts the voice back onto the recording without the narration drifting out of sync. This is that pipeline. A completion-gated playwright capture produces the screen video and the scene boundaries. The cloned voice synthesizes each narration segment, and every segment is measured. Then each scene is reconciled to its segment and stitched with the audio laid back to back. Because every segment starts exactly at its scene boundary, the narration simply cannot drift. You might ask, how do you actually keep the voice locked to the screen? The trick is to measure first. The pipeline records the screen completion gated, waiting for the UI to settle rather than a fixed clock. Measures each narration segment's real length, then retimes each scene to match. The audio is laid back to back. So a longer or shorter voice never accumulates drift. That's what makes the stack voice agnostic. I also wanted to be honest about the ethics. I cloned my own voice from my own recording with my own consent, and the audio is clearly labeled as synthetic. My line is simple: consent is the dividing line, disclose synthetic audio, and keep the data in your own control. And the hardest question I had to sit with: doesn't publishing this just normalize a dangerous capability? My honest answer is that the same 30-second clip capability already exists widely, and pretending otherwise helps no one. What I can model is responsible use, consent, provenance, and disclosure. That's why the ethics section in the post is deliberately two-sided, naming the misuse risk, not just the clean case. Thanks for listening. I hope this was helpful. If so, you can reach out on LinkedIn directly to get in touch with me, or head to my blog at schristoph.online. Let's keep in touch. Take care.